The concept of time for humans has always been somewhat tricky. It seemingly moves in one direction, but many natural laws appear to work backwards in time as well. Time seems to move at a constant rate, too, but we know that in the wider picture, it's actually completely subjective and can change depending on how fast someone is traveling. We still don't fully understand time as a species then, but scientists may have just made another fascinating discovery about it. This is Unveiled, and today we're answering the extraordinary question, did scientists just discover a new dimension of time?
Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content.
Because time is such a challenging concept to investigate, many aspects of it are arbitrary. Philosophers often have different concepts of time compared to scientists, and even our standard measurement system of time, made up of seconds, minutes, and hours, is simply how we choose to measure it. It's not as though it has to be that way. Breaking time down into intervals of 60 was first developed by the ancient Babylonians, who inherited their general number system from the Sumerians. Meanwhile, the length of our day is derived from how long our planet sees the sun in the sky, which means that a day as we know it is actually only really specific to Earth. As science has advanced, we've been able to define each unit of time more clearly. For example, the true scientific definition of a second is now how long it takes for a cesium atom to complete a set number of oscillations. This length of time is true time within our own structures for it. Zooming further out, we can view time as the fourth dimension of reality. Objects exist in 3 dimensions of space, but in order for them to experience change in any of those dimensions, time must pass. Space-time was a concept developed by Albert Einstein in the early 1900s to show that all of the dimensions, the 3 space plus time, can be collapsed into a single model that explains how they interact. Until today, that 4-dimensional 4D model has gone largely unchanged. So when physicists announced in July 2022 in the journal Nature that they've essentially created a new theoretical dimension of time, it's no surprise that people took notice. The study was held by a team at the Center for Computational Quantum Physics based in New York, although the experiments were staged in Colorado. And as it turns out, the discovery that was ultimately made wasn't exactly intentional. The team behind it were actually studying how to create a new phase of matter. But in the process, they ended up hosting a new dimension of time as well. At first, to create a new phase of matter, as was their intention, the team completed experiments in quantum mechanics. They wanted to create what's called a topological phase of matter, also known as quantum matter, which uses quantum entanglement patterns to build an all-new product. There's intricate science here, but what it comes down to is that different phases of matter are defined as such because they have what are known as different symmetries. When water is liquid, for example, the atoms within it are random and move around in space to fill empty spots. But when water freezes, it loses that freedom. Its symmetry has changed. The atoms within behave differently, and it has therefore become a new phase of matter. In essence, the breaking of the symmetry of atoms is what signals a change in the phase of matter for anything. But the team behind this latest study found themselves confronted with a further unexpected question. Because what if you broke the symmetry in time instead of in space? Led by the physicist Philip Dumitrescu, the team worked on a quantum computer with qubits in the initial attempts to create their new phase of matter. While regular computers use regular bits, zeros or ones, aka binary, quantum bits, or qubits, can allow something to be either a 1, a 0, or, because of quantum strangeness, both at the same time. This is important because it's this that allows quantum computers to be so much faster than traditional ones. And with the right know-how, it means that qubits could also, theoretically, be used to create that new topological phase of matter as they entangle with other qubits. In simplest terms, it's as though, in the quantum world, anything is possible, or at least nothing is guided by standard physics anymore. The problem is, however, quantum particles stop being quantum if they interact with the outside world in any way. And in this sense, they are extremely unstable and short-lived. To make the quantum properties last longer then, and to potentially create matter in this instance, the researchers wanted to stabilize the qubits by adding in time symmetry. Whereas spatial symmetry is just something that's repeated over and over in space, such as the atomic structure of a diamond. Time symmetry is such that the individual qubits will always be the same at certain points in time. To accomplish this time symmetry then, the team used a regularly flashing laser. By having the laser pulse continuously at the same interval every time, an apparent dimension of time could be imposed onto the quantum objects in hopes of stabilizing them. However, as complex as all that sounds, it didn't work. Despite the time symmetry added in, the qubits still barely lasted for more than a second. Their quantum properties almost instantly failed, and no new phase of matter was achieved. But this is where the idea for adding in another extra time symmetry came into play, as next, the team used another additional laser, one that produced a different symmetry, to almost shore up the conditions for their hoped-for quantum matter. By doing so, they were arguably now imposing 2 dimensions of time onto the quantum particles. 2 lasers pulsing at different intervals in a bid, again, to stabilize the qubits into matter. The second laser was pulsed according to the Fibonacci sequence, which is a non-repeating pattern that actually already occurs throughout nature. It can be seen in everything from the arrangement of leaves on a flower to the pattern of pine cones and the shapes of some fruits. Ultimately, by adding in this second Fibonacci time symmetry, the researchers were able to stabilize their qubits for a short time and therefore create the new phase of matter that they had originally sought. The stabilization still only lasted for a few seconds, but nonetheless for significantly longer than any other attempt made before. Most significantly of all, though, because of the additional time symmetry required to make the experiment work, it was as though the new phase of matter also only existed in a new dimension of time. Under ordinary conditions, it hadn't been possible, but by bending time to their will, the team were able to make it happen. So what's next? The study highlights a potential method for increasing quantum stability through dimensions of time. But what does that really translate to in the real non-quantum world? Well, for one, it's said that this breakthrough has the potential to revolutionize and fast-track our general efforts toward quantum computing and information storage. Anything to increase quantum stability or quantum coherence could lead to more viable and less error-prone quantum computing technologies. Currently, fully functioning quantum computers are still considered to be quite a way off. But for the team behind this study and for many watching on, the adding in of an extra time dimension could mark a vital first step along that path. Philip Dumitrescu, in an accompanying statement for the study, refers to the ongoing development of quantum computers as, quote, an open problem we're working on, end quote. It's tipped to become one of the most exciting and important technological advances in the near future, and this study may well have provided the key to unlock the door. As we step over the threshold into the quantum age, there are some predictions that quantum computing could quickly become a trillion-dollar industry. Such is the power and influence that it will hold over society. From chemical research to biological engineering, cybersecurity, encryption, and artificial intelligence, the scope for quantum tech is incredibly wide, even if the specifics are still somewhat ambiguous. The picture is clearing, though, and all it's taken is some major temporal remodeling to push the process forward. When you think about it, science in the 21st century is pretty incredible, because that's how scientists just discovered, or perhaps more accurately, built, a new dimension of time.
What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.